So, next to me is Artur Barseghyan. My name is Job Gansenvoort. We're developers at Goldmund, Wildebeest, and Wunderliebe. We're here to present the work we did last year to get a high-traffic e-commerce site to perform great, especially under stress. We'll discuss overall architecture, bottlenecks we found, solutions, and results. So, Vakantselij, they're sponsoring today's event as well, is an e-commerce company selling camping holidays. They have over 500 campings throughout Europe. Sorry. The company has a head office in the Netherlands, Eindhoven, and sales offices in 11 countries, and domains in these countries as well, .nl, .be, .ever. Traffic to the site is seasonal, so the peak is usually in the first 2 weeks of January, and especially on Sunday evening between 8 and 10, it's quite busy. At that time, there are about 600,000 page views per day, and a sustained load of about 2,000 page views per minute during the evening. The core of the system as it is now is the ISeries. It's an ERP system responsible for the products, the availability, and the transactions. This is an aging architecture that is being revamped. There will be a service bus with several components, each tailored to their specific task. And this architecture is being put into place piece by piece. The old website used to talk directly to the ISeries system, but to facilitate the change, the new website that we built no longer allows that, and the browser fires all its queries to the website. It's the search mechanism especially is quite Ajax heavy. So we were wondering whether the new website would be able to handle the load, and we were afraid it wouldn't. So the topic of this talk is the performance of the web server as measured in the number of page views per second that the site can handle. As a result of improving that performance, the user experience has improved a lot too. So during 2016, we gradually delivered this new website, first only to the Austrian visitors, and then step by step to all the Vakantselij domains. The browser requests are being handled by Apache, statics and media served directly. Dynamic requests go to Django under GUnicorn, and our database of choice is Postgres. A lot of the content in the system is retrieved from the ISeries backend. So I'll be honest, our minimal viable product felt a bit sluggish, even without load. And we started investigating the bottlenecks, and I have a few, most of them listed here. Each time we eliminated one of the bottlenecks, we'd run into a new wall, but over time, things have improved a lot. The order in which I will be presenting this today is more an outside-in view than chronological. So the server, we're running in a virtualized environment, so these parameters can be tuned. We're using a single VPS currently, partitioning the functionality over several servers. So far hasn't been necessary, but we could, of course. these Xeons do 5,000 bogomibs. Great. We started with 8 cores. There have been times when we were running with 40 cores even, but better caching brought the need down to about 16 at the moment. We're using 24, which gives us plenty headroom. You'll see the graph in the bottom right about the CPU usage. It's pretty okay. Virtualization platform allows us to scale these servers up to 48 cores and 192 gigabytes at least of RAM, so that is enormous. Web server that we use is Apache. Out of the box, the default multiprocessing module that Apache has is a pre-fork, which allocates a fixed number of processes to handle the requests. That is a safe approach, but we're not doing anything that is that requires the thread safety that pre-fork NPM brings. And it comes with a lot of drawbacks, especially allowing browsers to use a keep alive mechanism blocks idle processes, which severely limits the number of concurrent users of the site. And even under moderate load, this quickly became a problem. The setup time for an HTTP connection then would be long, and it would be waiting for processes to become available. So the event NPM solves that. It uses a single thread listening for incoming requests, and then delegates the requests to worker threads while managing the amount of worker threads needed between a predefined lower and upper bound. With the values that we picked here, Apache was never the bottleneck again during our stress tests or real-life load. Database, as I said, Postgres, we found some problems and inefficiencies there too. So we started adding logging and found that, well, it needs to, at least the number of connections needed to be raised a lot. 100 wasn't enough, especially because we use a high number of Django workers. But also, system would run out of space quite often. And as our server has more than enough RAM, we allocated generous amounts. So large shared buffers, large effective cache size. And this helps keeping the database in RAM mostly, which greatly reduces the accesses to the hard drive as well. We added logging to find slow database queries as well, where we chose 500 milliseconds as a, well, arbitrary threshold. This helped us identify logging issues with the Django session table. And, well, I'll talk about solving that later. But as a result of the tuning, the database calls were noticeably faster, and especially the number of slow queries really dropped. We're running Django under JUnicorn. We experimented a bit with the number of worker processes, because if this number is too low, handling of requests can stall, eventually giving timeouts. So the advice as per the JUnicorn docs is to start off with 2 times number of cores that you're using plus 1. We found 32 to be plenty and work rate. So sessions were an issue with the database, but with caching as well. I'll talk about that later. But typical usage of the site is anonymous. People are just searching for their next summer holiday. So we try to avoid usage of sessions as much as possible. We only use sessions for logged in users. These are site admins and content editors. We store the sessions in Memcached instead of Postgres because this is faster, but it's more volatile as well. So if this solution doesn't work properly, might be because Memcached doesn't have enough memory allocated or on a reboot maybe, then these editors will be forcibly logged out and have to log in again. For these types of users, we thought this was an acceptable risk, but it's not nice if it happens. The search is the most important part of the website. And this is mostly about the search page, but the widget that you see on the left here is basically available on each page of the site. So here's how this works. The yellow block on the left is a form containing several widgets for destination, like country or region that you would want to go to, the period, the arrival and departure time dates, possibly with a couple of days earlier or later. The travel group, like adults, children, pets that you want to bring. The accommodation types, mobile homes, tents, and other features and facilities like air conditioning or close to sea or anything like that. So the search API call returns two items. One is the set of all campings and their accommodations that match the form values. And that information is a plain list containing only IDs. This is to keep the results set small. It's less than 20 kilobytes always, and fast too. The second part of the return value is the facet count. That is the number of campings matching a particular item restricted by the other form widgets. And these results are displayed within the form itself. That is for the facet counts. So you see that we have 12 mobile homes available, 3 glampings, etc. Furthermore, in the header, which you'll see top right, we have 11 campings, so that's the total. That also yields the pagination. You see the pagination bar on the right. And the results area is then filled through a second API call. So we have pagination. The current page consists of 5 search results, which are the campings with accommodations that match the form values. And these are rendered through the search results API call. We try to make this as lean as possible too. For instance, you're seeing 1 photo per camping here, but actually that is a BX slider with about 25 photos in it per camping. And the template code to process those 5 times 25 photos would take about 60% of the total time of the search results call. So now we only include 3 in the results, which makes the first that you see and the next that you would see upon interacting immediately available. And as soon as you start interacting with the BX slider, we load the other photos. But that's just right before you need them and not any earlier. This well helped. So when searching, we're actually looking for available accommodations that match the selected criteria. And some data is rather static. For instance, a camping or accommodation usually stays within the same country. The presence of a swimming pool also doesn't change multiple times per day. The availability, however, does, because somebody might just have booked the last remaining mobile home at a particular camping. So we fetch all static search facts preemptively. We do that with a daily sync. From this, we create accommodation filter sets. For example, a set of all the accommodations that have air conditioning available. So when we actually perform a search, we query the ISeries backend for raw availability data, including only the date parameters. So this yields a set of available accommodations, which we then intersect with the accommodation filter sets for the selected search parameters. And this gives us the final search result set. But in that same pass, the facet counting is performed. So for each possible parameter value, the number of campings and accommodations that you'd get if that parameter was selected in relation to other selected parameters is calculated. And because these are all just sets that can be intersected, well, very fast, this is an approach that works really well. So why did we build a search ourselves instead of using Elasticsearch or Solr or well, any other search engine? And actually, this is because the code that we built wasn't too complicated after all. It's about, the core of it is about 200 lines of code, and it's fast. So after getting the raw availability set, all the filtering and faceting is done in less than 20 milliseconds typically. Second reason is that modeling this, especially the faceting in Elasticsearch wasn't that easy because we're filtering on accommodations, but the numbers that we're showing is the campings that have these accommodations. So the web server is making a lot of calls to the ISeries backend. And one of the reasons we implemented search, as I explained on the previous slide, is that these requests for raw availability is decoupled from most of the other search criteria, which increases the chances that results can be reused. So we cache these using memcached. That means that a user who's interacting with the widget and then selecting a country and region to go to, or that he wants a mobile home with air conditioning, etc., gets on each modification the facet counts updated rather quickly because the ISeries backend is queried only once and the results are reusable. So a second user searching with the same arrival and departure dates will typically reuse those cached availability information as well. So the maximum cache age is a setting per API call type, and availability caching in general is rather short, like 10 minutes to an hour. That depends a bit on the season. For some API calls to the ISeries backend, like for fetching the prices, the API allows a batch of accommodations to be queried at once. And of course, we use that for rendering search results because we're showing 5 campings at once on pagination. In this case, we cache the individual accommodation prices and not the entire batch. So we break down the search results before caching. More caching, but now between Django and the front end, or between Django and Apache. So we added Furnish, and it wasn't just add Furnish and poof. We had the site to be, adapt the site to be Furnish friendly. And that allowed us to make Furnish quite aggressive as well. As I said, an early observation was that we have many anonymous and few authorized visitors. And we took some extra steps to separate these authorized visitors, who are site admins and content editors, and these use a separate URL, which is uncached and limited to the local network only, and VPN. Public site URL is available only for anonymous users and cacheable. So on a GET request, Furnish simply strips all cookies and does that on a response to. And most GET query parameters, for example, those that you would get from Google Analytics campaign, are handled in JavaScript. So these are removed from the query as well, from the URL, to allow Furnish to do more caching. Django doesn't need to see those parameters anyway. We structured the pages and the AJAX scrolls to be as independent or anonymous and therefore cacheable as possible. For instance, the shopping cart, which is a suitcase icon in the top right of the site, and CSRF tokens that you would use for forms are taken out of the normal process and instead handled separately. This yielded an overall hit rate in Furnish of about 40%, which is highest on CMS pages, which is great because those are expensive to render. The hit rate is lower on the search API because there's a wide variety of possible search parameters. But anyway, these API calls are pretty fast anyway due to the reuse of partial search results. So I think overall the hit rate is quite good. We're halfway our presentation now, and I'd like to summarize the approach so far. We've looked at the full stack, server, database, Apache configuration, Furnish, reverse proxying, for which we adapted the site. Search API is to be simple, fast, and cacheable. The search mechanism itself to be smart using set operations. And heavy reusing of queries to the ISeries backend. But there's more that we did, and Artur will now take you on a tour of Django and Django CMS-specific optimizations, focusing on the ORM.
Thank you, Jo. I'll be quick. Optimizations take time. It may seem endless, and in most cases, you won't reach the limits of no optimization further possible. But there are a couple of key factors to consider. Profiling tools, Django has some. Just make sure you don't accidentally enable it on staging or production. Surprised? Just joking. Django debug to bar template profiler. It's another one. One of the best add-ons ever for the debug to bar. Just pip install an extra panel to install apps and debug to bar panels. I discovered it about 2 years ago. Be careful though, it affects the page speed drastically. Django debug to bar is an excellent tool, but page rendering limits timing lie. It needs to render a lot of HTML as well. The more database cache, etc. information show, the longer page loads you get. As I mentioned, some panels affect the page load speed drastically. Don't be scared though. In production, or with the bug set to false, things aren't that slow. However, it's not an excuse to avoid optimization. When you're outside of the request response cycle, you're use logging to get an idea of what's happening in your system. Just a couple of models and use. They aren't anyhow related to Van Casselij, still are based on issues that we experienced there. Imaginary app, publisher, author. Book model with man-to-man relation to author and foreign key to relation to publisher. To name a couple of tips. Make use of select related and prefetch related for fetching a related object at once. Make use of only and therefore, typically use case listing views, but use them with caution. Use annotate and aggregate for calculations on database level. When fetching IDs or related items, you only need ID. Use field name underscore ID instead of field name .id, since the first one does not cause a table join. Consider using values or values list for listing views where possible. A listing of books, about 2,000 in total, with the following information: book title, names of all authors of the book. Remember the man-to-man relation, separated by commas. Show publisher name, the foreign key relation. Show number of pages, same model table, and show the price, same model table. Bad example. 4,000 queries, slow page load. Sad, isn't it? Let's improve. We'll use select related for dealing with foreign keys, and prefetch related for dealing with man-to-man relations, only for fetching desired columns only. Just putting things together. 2 queries, much faster page load. Surprised? Let's improve further. We're going to add values and annotate. It's how it would look. Note that no prefetch related, select related are only is needed here. Values will take care of it. 1 query left, page rendered 4 times faster than the improved example. Nice, isn't it? Some of you may ask, but what is a group concat? Shall I go to Page's spec? The custom aggregation functions. Django makes it very easy to write custom aggregation functions. There are a lot of bundled ones as well, such as sum, average, min, max, etc. If you use Postgres, make sure to check the dedicated contrib package, contrib Postgres aggregates. In case of Postgres, you would be using a string ag for that. But for now, it's just a tiny custom aggregation function which saves us a lot of page rendering time. Surprised? I'm going to repeat it more than once today. Our next example, create 50 records. A bad way of doing that. 98 queries, 40 milliseconds, page rendered within almost 600 milliseconds. Sad, isn't it? Let's improve. Use bulk create. Here we create 50 objects at once. Of course, you should be using factories, but it's out of scope. Only 2 queries, a lot times faster. Nice, isn't it? Surprised? Those of you who worked with Django debug to bar may want to say, what the hell is this guy talking about? It's non-thing, and say something new. We use it 5 years already. Well, others would say, yeah, it's nice, but it doesn't handle the AJAX request and JSON responses at all. However, it's possible with Django debug to bar false. A single pip install, tiny additions to your configuration, middleware classes, middleware, and you can debug AJAX use and JSON responses just the same way, almost. Just add !debug to bar to any AJAX or JSON response view, and you have the same debug to bar there. Surprise? You didn't know about it, right? You may think, hey, stop showing these 2 pictures. Let's go on. One important thing, as I already mentioned, I'll be saying it more than once a day. Don't make queries in a loop, no matter what kind it is. Database, cache, elastic, whatever, just don't. Move all your queries outside the loop, fetch it once, and reuse it in results set later, in a loop. Insert, update, delete in a batch. Another nasty example. And the page ID is the correspondence ID of the CMS page. You may think, but who writes such things? Or it never happens in practice. But it does, and you have to deal with it. You want an example, a serious example of Django app where such things happen? You ask for it, Django CMS, pretty serious, isn't it? Did you know about it? Surprised? Okay, let's see how we can do with it. A bad way of doing that in a loop. Imagine you have 100 items, you have 101 database queries. Bad. Let's improve. We can't use select related or prefetch related here, but we can grab data at once and do the necessary joins in Python. No additional database queries and missed cache hits at all. A little bit of code, but it's worth it, right? Surprised? Now, some things about the cache. And I'm going to talk about Django cache, no memcache to logmem. Don't mix it with Varnish. Django cache can dramatically improve your site performance, but misuse can lead to slowdowns. First of all, analyze. Use Django debug to bar to track down what causes it. In many cases, it will be possible to refactor the slow part. Use template fragment caching where possible. If you have more than 500 repetitive cache hits on a page, something isn't right. Identify heavy parts of your template with template profiler panel. Try to optimize the heavy parts, and after that, it can be done. If it can be done, cache those heavy parts. Document in the code why you cache certain parts, and keep a track of all cache usages in a separate section of your developer documentation. Clean up your templates, remove unused imports, try to avoid queries in the loop. If you work with Django CMS, beware that any use of page URL or page attribute tag will make a lot of queries in the loop. Reduced number of queries often leads to performance boost, but still, reduced number of queries does not necessarily mean that your database is used efficiently. Use explain statements that's provided by Django debug to bar to identify the heavy parts. Fine-tune your queries. Add indexes when necessary. In development, run 2 instances of the project, one with a change, another one without. Always compare the before and after. Test page load speed with caching on and off. Test the first page load and the second page load. Avoid use of context processors and middleware that do make database or cache hits. If you need to have some data in templates, use template tags or specific templates to fetch it. In any case, if you absolutely have to use it, make sure it's lazy, unless it's impossible by design. Some tricks specific to Django CMS. One thing you should know is that once you have integrated Django CMS into your site, all your vanilla non-CMS related views will become heavier. There will be additional checks and queries fired by CMS middleware and CMS context processors. It may seem weird and irrelevant, but that's how it is. Sad, isn't it? Wait, but there's a fix for it. Almost clean. And if there aren't, try to find new ways to optimize that. Surprised? Try to avoid usage of page URL or page attribute tags on IDs. Instead, pass complete page objects only. Apply some tricks to the query sets to fetch the page objects efficiently. If you list a lot of Django CMS page objects with URLs on a page, don't use page URL tag at all. Instead, use customized template tags, which fits your needs better. Our next use case, a sitemap with about 200 CMS pages. A bad example. 2,000 database hits and 3,000 missed cache hits. Sad, isn't it? Improved example. The code I'm going to show is not as simple and obvious. It's what worked well in the project I worked on, and you should be not applying it everywhere. However, you can, you know what to do, and you can change it and fit it better to your needs. For now, let's move on. That didn't fit on one page. Okay, then it's over. Yeah. Yeah. As a result, improved performance. Used get render query set on CMS plugins because by default they're not applied. Load testing. Use Apache demeter. We measured before, we measured after, and after was way better. We're happy. That's it. And these slides are available. You can download them. Thanks.
Well, thank you very much. Unfortunately, the time's up. We'd like to hear more of it, but you can look at the slides online. Yeah, sure. I guess everybody has questions, but you can ask them later on. Okay, thank you. And we have a small present. I don't know which, yeah. Here you go.